Okay. So we have ended our previous class over here. On formation of cations, and we discussed that the group 1 elements and the group 2 elements and the group 3 metals. In these metals, this boron is not included, the first element of group 3. Okay. So they lose their valence shell electron and become a cation. So when they lose their valence shell electron, their inner shell becomes the valence, and it have 8 electrons, which means it is completely filled, so they become stable. Okay, we have noted down this. So normally you must remember that the elements which are on the left side of this red line, this staircase, are all the metals, and these metals have a tendency to lose their electrons. So these usually lose their electrons and always form cation. Okay, okay, Khatija. So
yes, sir.
Here we go. Now, first understand this, then copy down. Okay. So what is happening over here? That there is a sodium atom. How many electrons it have? 11.
11.
2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. So in its outermost shell, there is a 1 electron. So what it will do to become stable, it loses that 1 electron, and as a result, it becomes a sodium ion with the 2 electrons in the first shell and 8 electrons in the second shell, and there will be no electron in the third shell. The electron which was in its third shell is lost, is removed. Is this clear? So see, when it have a 11 protons, and here it have a 11 electrons, as it's an atom. So if we add them, the charge of 11 proton is plus 11, and the charge of 11 electron is negative 11. So we got the net charge 0 if we add them. So that's why if you see, there is a no charge on it. But if you see, there is a charge on it, and that charge is plus 1. So why is it so? Because if you see, the protons are still 11, so there is 11 positive charges, but the electron become 10, so it have 10 negative charges. So if we add them, we got a charge of plus 1. So that's why this ion carry a plus 1 charge. Is this understandable?
Yes,
Yes,
sir.
Khadija?
Yes.
Okay, now if you look at an electronic structure, how the electronic structure is being made. So see over here that if you look over here, that the sodium atom have 2 electrons in its first shell. Then in its second shell, there are 8 electrons. And then 1 electron in its third shell. So to become stable, what it do, it loses this 1 electron, and that electron is not now the part of an atom, and when it is removed from the atom, that atom turns into sodium ion. So whenever we draw the electronic structure of an ion, of any ion, we enclose it in square brackets like this, and we put a charge, as we know that how the charge is there on sodium ion, because there is a 1 electron lesser than proton. That's why it is getting a charge of plus 1. So it's from group 1. If you see the periodic table, it is from group 1. So any metal from a group 1, when it becomes ion, it always become ion with a plus 1 charge. So because in their valence shell they have only 1 electron, so they loses this 1 electron and always become a plus 1 ion. Is this understandable?
Yes,
okay.
sir.
So now note this down. Yes, Khatija, hope you understood.
Yes, sir.
What about you, Manahal? Then, have you drawn the structure as well? Okay. Is Khadija, are you also done?
Yes, sir.
Okay. Now, in the similar manner, if I ask you, do for calcium, its atomic number is 20. So, first you will write the equation in this manner as you have written for sodium. Then, below the equation, below the atom, its electronic configuration. Below the ion, its electronic configuration. Then the electronic structure as well. Okay, so do it for calcium. Khatija, as you do, show it to me, WhatsApp me, and Manahal, I will be checking yours.
Okay.
So how many electrons it will use? So write 2 electrons. See, we have 1 electron, so 2 electrons, 2 and 2. No, not here, here. Because there are 2 electrons, not which have been lost. 2 and E minus. Minus the minus charge on the. Yes, here we have charge of plus. So now towards electron configuration. Electronic structure. So when it becomes time, we just discussed that we always enclose it in a square bracket. Then put the charge. How many electrons are lost? So that 2 electrons. Like this, see, we wrote down 1 electron. Good. Now start with the aluminum with that atomic number of 30. Khadija, are you done with the calcium?
Yes, sir. I sent in the chat.
Okay, you sent me in the chat. Okay, but see here in before the arrow you write C instead of calcium instead of Ca. You have written
Yes,
carbon. Okay,
sorry. Yes.
so see, it would be like this. So we have observed that calcium ion is formed. So if you see the periodic table, you find calcium in a group 2 and it have 2 electrons in the valence shell. So all the elements of the group 2 have 2 electrons in their valence shell. Whenever they become ion with a positive 2 charge. Is this understandable?
Yes.
Yes, Khatija?
Yes, sir.
Okay, now do it for aluminium quickly. Okay. Very good. Is Khatija, are you done as well?
Yes, sir. Done.
So, see, here we have, right? So, aluminum is in which group? Is in group 3. So, all group 3 elements forms ion with +3 charge except boron. That is the first element. It usually doesn't, because it's a non-metal. So why is it so? Because it is a non-metal, and in group 1 and 2 all are metals, all elements are metals, so that's why they all becomes a cation with a +1 charge and a +2 charge respectively. Is this understandable?
Yes.
Okay, now let's talk about anions. So the elements which have a more electrons in their valence shell, like if they have a 5 electron or 6 electron or 7 electron in their valence shell, so they need only 3, 2 or 1 electron to be stable. So instead of losing their valence electron, they are going to gain the electrons in their valence shell. And when they gain the electron in their valence shell, they have 8 electrons in their valence shell and they become stable. So the elements which I have highlighted over here from group 5, from group 6 and group 7. Is this understandable? So these are non-metals, and non-metals have a tendency to gain the electron. Okay, first note it down. Then if you guys got the concept, so try to do it for nitro. Okay, let me discuss one example of a nitrogen with you, then the rest of the examples you will do. Okay. Is this understandable?
Yes.
Yes, Khatija.
Yes. Yes.
Done? Is Khatija, are you also done?
Yes, sir.
Okay. Okay, now have a look at nitrogen. Nitrogen have 7 electrons in total, as its atomic number is 7. And if you see, nitrogen is over here in group number 5. See? Right? So, if we see over here, so see, nitrogen's electronic configuration is going to be 2,5, right? So
Yes.
it means in its valence shell, how many electrons are there? 5. So it needs 3 electrons. So say that's why it is gaining 3 electron. And when it gains 3 electron, its electronic configuration becomes 2,8. Is this understandable? Okay. Now,
Yes.
being an atom, here it have 7 protons, so that's why it have a +7 charge, and have 7 electrons, so that's why it have a -7 charge. So the net charge is 0. But when it becomes a nitride ion, it have 7 protons, so 7 positive charges, but 8 electrons, so 10 negative charges. So the net charge we got is -3. That's why this ion have a charge of -3. Now there is a one thing that if you guys have noticed, when we are talking about the cation, see, the element is aluminium, right? And when it forms a cation, we called it aluminium ion. The element is calcium. When it formed a cation, we called it The element is sodium. When it forms a cation, we called it
Sodium
so
ion.
for a cations, there is nothing change in the name of the element, but in the suffix we just put a ion in the name of ion, right? But when we look at a negative ion over here, if you see, the element is nitrogen, but when it become a negative ion, its name is nitride ion. So remember, whenever an atom gains electron and become an anion, the name of the anion, we would replace the last part of the name of element with the ID. Is this understandable?
Yes,
Yes,
sir.
Khatija? Okay, now have a look at the electronic structure. Here we have a nitrogen atom. So see, we just made one difference. And what difference is that? If you recall, the initial electronic structure we have drew for the formation of cation, we put the electrons with the dots. And here we are putting the electrons with the crosses because the electrons which they have lost, the cations have lost, are actually gained by these atoms to form an anion. So see, it is gaining 3 electrons, and when it gained 3 electrons, so see, these 3 electrons are actually represented by the dots. So it means these are those 3 electrons which are actually gained from any atom which becomes a cation. Clear? Yes,
Yes.
Khatija? And the electrons which this atom already possesses must be represented by crosses. If we, for example, if we made the electrons of the previous one, where we are forming a cations with the crosses, so here we do it with the dots, and the one again we mentioned or we draw them with the crosses. Okay, is this clear?
Yes.
Okay, so it's in group 5. That's why it have a 5 electron in its valence shell, and it is gaining 3 electron to become a stable. So it means all the non-metals in group 5 will gain 3 electron, right? So draw this one quickly.
Sir,
Yes.
I have a question that in group 5, not all the elements are non-metals.
Yeah, that's why if you uh, recall my statement, I said that the non-metal elements of group 5 when gain electron, they become a ion of a -3 charge.
Okay, okay, sir. Okay.
See, and if you see, I have just highlighted only 2 from group 5. So these are the one which are non-metal, which I highlighted over here. Okay.
Yes.
Okay, Khatija. So non-metal elements of group 5 forms ions or anions with -3 charge. Done? Yes, Khatija, are you also done?
Yes.
Okay. Now, if I ask you to do the same thing for oxygen with atomic number 8. So when oxygen becomes an anion, it will form an oxide ion. Right? Get -3 on the Yes, Khatija, are you done? Okay.
Yes, sir. Done.
Okay, Khatija. So if we look over here, okay. So see over here, it have a 6 electrons in its valence shell, right? That's why it is
Yes.
gaining 2 electrons, and when it gains 2 electrons, it have a 8 electron in its valence shell. So initially in an atom, it have a 8 protons, so +8 charge, and 8 electrons in total, so -8 charge. That's why its net charge is 0, and we didn't put any charge over here. Then 8 protons in the ion, so it have a +8 charge, and 10 electrons, so -10 charge. So if we add them, we get a net charge of -2. That's why it got a charge of -2. So see over here. See, in the valence shell, there are 6 electrons, which is of oxygen atom. And when it gain 2 electrons, these 2 electrons are over here paired with the unpaired electrons of oxygen. and we enclose it in a square bracket and put a chart over there. Is this clear? Yes,
Yes, sir.
Khadija?
Yes,
Okay.
clear.
Now do it for chlorine. So when chlorine becomes an anion, its anion is called a chloride ion. Right? Yes, done.
Yes, sir.
Okay, Khadija.
Yes, sir. Done.
Okay. Okay, so see, it's like this. Is it clear?
Yes.
Okay, so we have observed that how a group 1, 2, and group 3 metals form positively charged ion by losing their valence shell electron, and the electrons that are lost by these elements from group 1, 2, and 3 are gained by uh, the atoms of the elements from group 5, 6, and 7, the non-metal elements from group 5, 6, and 7, they gain the electrons in their valence shell to become a negative ion. Okay, so now what is there? A positive ion is formed and a negative ions are formed, right? So these positive and negative ions are going to attract each other. Okay, so after when these ions are formed, these ions start to attract each other. Why they are start to attract each other? Because they have opposite charges. So they start to attract each other, and as a result of this attraction, what will happen? That there is a formation of a giant structure, which we called giant lattice of ionic compound. So what will happen that if you recall from the start, the metal elements of group 1 or group 2 or group 3 loses the electrons from valence shell to become a cation, which means positive charge ions. And in the similar manner, the non-metal elements from group 5, group 6, and group 7 gain the electrons in their valence shell to become an anion, which are negatively charged. So there are so many positive ions and so many negative ions. Then those positive and negative ions start attracting each other, and due to this attraction, they are going to form a giant lattice of an ionic compound. Okay, so what is ionic lattice? Lattice is the term used for structure. So ionic lattice means a structure in which there is a regular arrangement of oppositely charged ions, which means that the positive ions and the negative ions, which are actually positioned at alternate position of each other, and they all are held together due to strong electrostatic forces of attraction between them, like this. If you see in this structure, is this understandable? So this is a
Yes.
part of a lattice only. It is not the whole lattice. You are seeing the diagram. It is in actual. It is extended from its right, from its left, from its top, from its bottom, from its front, from its behind. From everywhere, it is actually extended. So, and we are just showing one part of that structure. Okay, just note this down quickly. Okay, Sanya, that's fine.
Hello, sir.
Yes, are you guys done?
Yes, sir.
Okay.
Hey, sir, can you tell me which topics we have covered today so that I can
We,
prepare?
we have started with the formation of cations. If you were in the last class, we ended the lesson over there, right?
Okay, okay, sir, got it.
So we continued from there. We discussed about how the cations are formed. Then we discussed how the anions are formed. Then now we are discussing that when these cations and anions are formed, then they are going to form an ionic compound.
Okay, sir, sure.
Okay, so if you see at this structure, in this structure, there are sodium ions and the chloride ions, right? So if in this structure, we observe that the number of sodium ions and the number of chloride ions are actually exactly equal. So that's why its formula become NaCl. Okay.
Yes.
Okay. But if we look at a, for example, another compound, another ionic compound, a magnesium chloride. Its formula is MgCl2, which means there is a one magnesium ion and a two chloride ion. It is indicating that in the giant ionic lattice of magnesium chloride, we have magnesium and chloride in the ratio of 1:2. So the formula of any ionic compound does not tell us the exact number of ions in the lattice structure, but they do tell us the ratio in which that ions are actually existing in the lattice. Is this understandable?
Yes.
Okay, so note this down and we will be ending the class over here. And from here onward, we will continue next class.
Sir.
Yes, Khatija and Sania, are you guys done?
Yes, sir. I have a question.
Yes, sure. Ask.
Sir, when the two ions are equal in number, equally charged, like if they are equal number of sodium and chlorine, so it means that they are telling the number of both of them. But if they are not equal, so they will always tell the ratio, right?
No, in the here we are also getting the ratio in sodium chloride as well. They are in equal number, but we don't know exact number of sodium ions and the chloride ions. Okay.
Okay.
We just know that they are in equal in number. And here we got in magnesium chloride, we know whatever the number of magnesium ions are there, the chloride ion must be double than the magnesium ions.
Yes.
Is it clear
Okay.
now?
So in both the cases, we know the ratios and numbers also.
We in both the cases we got the ratio in which those ions are present instead of the total number of ions which are there in the lattice structure.
Okay.
Okay. Okay. So take care. Allah Hafiz.
Left.